But Nick, what did you want to bring up? So we just get into it before we get back to Jack.
Oh, you were talking about gravity, and
what does it mean to you?
Well, I guess I was just here if you had any questions about gravity. I did see in the comments, like, there's this sort of confusion between what is gravity, what is weight, what is mass, and what is density. While they are related, they're all different things.
Right.
For example, density is okay. So in physics, we have what's called a vector and what's called a scalar. And I'll try to explain this as simple as possible. Like, for example, temperature is a scalar. It's 67 degrees in my room right now. Temperature doesn't have a direction. It's just a value, whereas a vector has a quantified value and a direction. For example, we could say,
hold on, Nick, give us the cliff noted versions. We can get into this another. Give me your cliff noted, give me your postulation, give me your point.
Well, okay,
and then we'll go from there.
Well, weight is a force. Okay, so whereas density is merely mass per unit volume. That's all it means. Density doesn't have a direction. It doesn't go up, doesn't go down, doesn't do any of that. So whereas weight is a force. It's an object's mass multiplied by gravitational acceleration created by a gravitational field. That's all.
Right. So
I know we say downward because
what's the proof of the gravity? Can you provide the experimental proof of the gravitational field?
Well, gravitational fields, that's a much more complicated question. I don't really have a Cliff Notes version of that. I'm
just asking you what your proof is for the gravitational force.
Well, that would be general relativity.
Right. That's so a theory is your proof. The theory is the proof. Is
well,
what
a theory is again, this is a common misunderstanding. A scientific theory is proof. Unlike, like, for example, I have a theory that Jack in flow state will make up versus a scientific theory, which is a collection of facts that lead to a conclusion.
Right. So science. So you're basically redefining what science is. Also, you just gave me the standard scientific answer, Nick. So you just told me what I could just read in Google. That's what you just told me.
I am a
like, is that
so I would give
okay? Well, do you know my background? What does it matter? You don't know my background either. I don't care if you're a scientist.
No, I'm not disagreeing with you.
All right. I mean, okay. So what's the difference?
Scientist, what science is? You're going to get a
okay, right. So you're going to ask the scientist who gave me the pseudoscience definition, which just came straight from Google, about general relativity, Einstein's 1910 bullshit theory that's non-demonstrable. Look, I'm willing to have this conversation with another time. I thought you were going to give me something good. You gave me Google, Nick.
Well, honestly, relativity is irrelevant. I mean, we can talk about Newtonian gravity, and all I wanted to say is that
why don't we talk about your science degree? Why don't we talk about how smart you are because you have your science degree? Can we talk about it? Because you're scientist.
No, all I'm saying is just what density is. Density.
Just call yourself a pseudoscientist, Nick. Cut down to it. At least be appropriate in how you define yourself.
Well, if you want to call me a pseudoscientist, that's your right. Okay.
Well, because you basically just told me that science doesn't involve, proofs, just conjecture.
No, science is a collection of facts that lead to a conclusion.
No,
I mean the scientific method is a philosophy. It's, we collect data and we see where that data leads us, and it leads us to a conclusion.
That's research. That's research. For example,
plate tectonics, is the theory on why earthquakes occur.
Science is a method to elucidate the cause of an effect that we observe as a natural phenomenon.
Yeah, that would be an incorrect interpretation of science, but
okay, right. That's that's not the one that you like because it doesn't conform to your agenda. It doesn't conform to your religious belief in pseudoscience.
No, I don't have a belief. I'm just telling you that
you just don't know. You just don't.
Definition of density,
right? I'm not disagreeing with that. So how does that relate to what you're conjecturing as a force of gravity relating to the bending and warping of space-time?
Well, we don't even have to get that complicated. Let's just look at Newtonian gravity. I mean, objects fall. I mean,
Okay, yeah,
pretty
objects
easy. You
fall.
can see it.
What does it
See it
have
for
to do with
yourself.
Newton? Objects fell before Newton, right? What does it have to do with Newton?
Well,
Objects
the Earth
fall.
existed before humans. That doesn't mean the Earth doesn't exist.
Well, we don't know any of that.
Well, we do. We do. We have evidence.
What if this Earth was made
Um,
for humans? So you
uh,
know that this Earth
Newton,
exists without
however,
humans
tried to
because
explain
every
why.
major
Well, actually,
religion of the
Newton.
world and every major spiritual thought in this world says that the Earth was created for humanity. Now, I'm not espousing that as a scientific belief, but just to say we know that the Earth existed before humans is a falsehood.
No, we have evidence because we know that the Earth has been around longer than humans. Therefore,
You're just Google. Dude, I'm going to call you Google. Can I call you Google instead of Nick? You're just giving me Google.
No, that's the information on
you
Google.
You think you're smart. You think you're intelligent because you could just regurgitate fucking a search engine, bro.
I came here to answer any questions you had about gravity. It seemed that you were confused about density.
No, you tried to educate me on gravity. I wanted to have a discussion about gravity. Okay, you're giving me the standard model of physics, dude. You're just giving me standard model. That's it.
Well, I'm very well versed in the standard model of physics.
Okay, well, I feel bad for you because you wasted a lot of time on a bunch of nonsense.
Not really. But, you know,
yeah, really,
it pays
really.
Well. It pays well.
Really. I bet it does. Guess what? When I was the sucking the dick of this satanic beast system, I was getting paid pretty damn well too, Nick. Yeah, but I woke up and I decided that my soul was worth a lot more than the fucking bullshit shekels that they were throwing me for fucking perpetrating their bullshit system. Unlike you.
I'm glad that you found yourself. A lot of people struggle their whole life to do that.
Right. Okay. So you keep getting those shekels rained down on you.
I'm sorry that
you keep dancing like a little fucking monkey for your controllers. But you just keep being the little dancing bear for the fucking satanic elite controllers, and you'll be
more free by just accepting your theory. I don't think you understand.
Right. This is the same argument I get from you. You know what down is? If you take a plumb bob and you hold it, that's down.
Down's a direction.
Right. If you take a plumb bob and the direction it points, that's down. Plain and simple.
Due to the
and guess what? That doesn't deviate anywhere. Right. So you just added the part about the gravitational pull.
How does the moon
that's your theory. That's the theory.
How does the moon
I don't know how the moon stays in orbit. I don't even know that it is in orbit. I don't care to know. You must have missed the beginning of my show where I said that doesn't matter to me.
Then we're not talking science. Then we're not talking science. I misunderstood.
No, that we are talking science because science is about things that can be demonstrated through experimentation. Don't talk over me. Science is about things that could be demonstrated through experimentation, things that could be observed, measured, tested, and repeated. How can the moon be measured and tested? It's just something we see in the sky. You can't perform a scientific experiment on the moon
know how to do it.
Unless, because I don't know how to do it. Well, what do I need? A rocket ship?
Well, I'm not going to argue with you. You can.
Okay. How do you?
I'm going to watch. I'm going to watch the drama because that seems to be more at your intellectual level.
You're going to run? You're going to run. You're going to run because I'm destroying your religion of scientism that you love so much.
Good day.
I'm destroying the religion of your science that you love so much, and you couldn't take it, and you showed yourself, and you ran. Tell me you could perform experiments on the moon to tell me what it is. You're a clown and a joke, and I respected you until you ran away, if you want to know the truth. I just thought you were deluded, but you showed yourself like all of you. All right, so tell me about you, Nick. So you're a scientist, huh?
Sometimes.
Well, you said is that you're a scientist like by profession? I mean, that's very broad
work,
right?
People always ask like, "What do you do?" And we're so used to saying that question is like, "What do you do for money?" It's like, well,
right.
What we do for money doesn't.
All right, so let's get into this a little bit. So you say you're a scientist. So here's the thing. My position on, the term scientist is anybody could be a scientist. It requires nothing but the ability and the desire to participate in the scientific method.
Yes.
What are your thoughts on that?
Well, so my field is physics, specifically nuclear physics. And I study it because I want to know what exactly we're made of at the subatomic level. You know, how low, how small can we go? We have, you know, there's a big misconception with science that people become scientists and science knows everything. We don't know anything. I mean, if science knew everything, then I wouldn't be a scientist. There's nothing to learn. Um, and I guess the philosophical reason why I do it is I believe, you know, all of us at some point in our life ask, who am I? Why am I here? What is the purpose of all of this? Um, and there are many ways to answer that. You know, I looked to religion, didn't answer the questions. I still had more questions. And I'm not saying that science is answering those questions, but I feel as if, you know, I'm at least getting closer to it. I'll never get there, but, you know, none of us will ever will. But it's the you know, this unsatiable curiosity that humans have. You know, we just want to know, why are things the way they are.
Fair enough. So you and I can agree on that, that science is a method that we can use to discover the world around us. It's a method to begin an objective pursuit in an effort to understand the world around us in a way that tries to get beyond our own subjectivity and our own bias. So you and I could agree on the importance of science and how science can be used to prove things. If anything could prove a thing, it's science.
Yeah,
Would you agree with me on that?
I would agree, but not to get too far in the weeds, there is also that sort of misconception that, you know, science is out to prove things. That's not necessarily true. What science does, it allows us to make predictions. It allows us to make predictions. For example, right now we're using a computer which is built of integrated circuits, transistors, stuff like that. I mean, that's all science. That's all electromagnetic theory. Once we understand how it works, then it allows us to, you know, design computers and build stuff and, you know, do stuff. Which I know there's some debate about this. Who's that? There's the Machine Lies. I know, you know, his views on technology are a little bit different than mine, but, you know, I would argue that as humans learn more technology, in some ways it makes our life better. Of course, technology is used for evil too, but, you know,
all right, so here's my problem with the modern term of science. Science has become basically personified. All right, science has basically now been relegated to people and institutions and organizations. And that's my big issue, because people will just claim science. They will reify science, science, science. That's why I conjecture it as a religion at this point, because I think at some point the modern interpretation of what we call science has deviated from its fundamentals. And that's why I categorize it as pseudoscience, because when we talk about things, as you did earlier, about Newtonian gravity, Einsteinian gravity, and gravitational forces, and I ask you about evidence and experiments to prove these things, and then I'm presented with theories, well, that to me is completely antithetical to the spirit of science. And that's my big issue with many of the modern schools of thought, modern academia, of course, and modern culture, is that we're presented with things as if they are fact, but upon scrutiny, we find that they're merely conjecture. And that's my big issue. So, you know, you're into physics, nuclear physics, and physicist. Well, I often look at it like this. We're presented with a standard model of physics, and much to what you were alluding to, it involves the concepts like subatomic particles, gravitational forces, and orbits in space. To me, they are all part of the same ideology, right? They are one and the same. The micro world and the macro world are defined by our modern physics by the same principles. Now, again, I see one demonstrable force, and that to me is electromagnetism. To me, that's substantiated. When we talk about like weak nuclear forces, strong nuclear forces, and the gravitational force, I always say, what's the evidence besides just reifying science and chanting over and over again that there is proof, and theories are just not understood by people like me? So maybe you can help me when I say, where's the proof of Einsteinian gravity based on the general theory of relativity? And where's the proof of these subatomic forces that are posited? Maybe you're going to be the perfect person to ask. If you're a physicist, you might give me information that I'm not aware of.
Well, you brought up a few points. I totally agree with you that science for a while has been institutionalized. I mean, speaking of electromagnetic theory, there's a lot of electromagnetic theory which came from this. I call him an experimental physicist, Michael Faraday. For example, even in your microwave, there's something called a Faraday cage, which prevents the microwaves going out. But even back then, he didn't come from money. He didn't go to the top schools, and many scientists rejected him. You're not a real scientist, but he was doing experiments just in the lab. It's sort of ironic. There's this big equation called the Faraday equation, which I'm sure Michael Faraday himself couldn't solve. Now, you mentioned electromagnetic theory, and I've heard this before. I find it interesting that
it's not a theory. I just said I believe. No, what I said was based on the way I evaluate physics. Electromagnetism is the only force that could be demonstrated. I didn't posit a theory around it. I'm talking about the four forces that we're presented with that you as a nuclear physicist, you're aware of. There's four forces that they give us. They're proposing more actually. But there's four in the standard model of physics.
Yeah.
Well, to me, electromagnetism can be demonstrated. It's something that we can see, we can test, we can verify and repeat. But when I'm presented and I evaluate the gravitational force and the two nuclear forces, I am hard pressed to find any evidence. So I'm asking you, maybe can you provide evidence, experimental evidence for the two nuclear forces and the gravitational force?
Let's avoid the strong and weak force for now. Those are I mean, I know like in the standard model, you're correct that we have what are called four fundamental forces: gravity, electromagnetism. Us physicists are very creative. One's called the strong force, the other one's called the weak force when you get to sort of the atomic level. But what I mean by the electromagnetic force comes from what we call electromagnetic theory. And you're right. I mean, we know it because we have these collection of facts, including stuff which Faraday came up with, Coulomb, bunch of other physicists. We don't have to get into that, where, they conduct experiments, develop equations, which then can make predictions, which, like I said before, I mean, electromagnetic theory is vital when it comes to just what we're doing right now, talking over the internet.
All right, so let's get into it. So then where are the predictions that could be made with gravity? What are the predictions that could be made with the theory of gravitational force?
We can predict that objects will fall at a certain rate. Or actually, let me make it simpler, that any objects with mass are attracted to other objects with mass, which is proportional to the size of those two masses. In fact,
all right, so I know that's the theory about mass attracting mass, but I'm asking for the proof.
Well, the proof is we observe it. I mean, for example,
hold on, because hold on,
it's going to fall.
It falls down.
Yeah, but not only is it going to fall down, it's going to fall down at
9.8 meters per second squared. Yeah. Exactly, that's the rate. Now, here's the thing. And what I'm asking is, where's the proof that there's mass on the ground that's attracting it due to the bending and warping of space-time, which is gravitational theory? That's what we all can see, that there's a natural law that dense objects, when they're denser, relatively speaking, to the medium that they're contained in, they will fall down. If they're lighter relativity, they will go up. You and I could both agree on that. But to say the ground is attracting it, I'm asking you, you know, how can that be proven to me? So I can then say, okay, well, yeah, there's a demonstration that mass is attracting mass.
Mm-hmm.
Because
Wait,
I can provide. Go ahead.
You brought up a great point. You brought up a great point. Why do masses attract each other?
Not why. We don't. You haven't yet proven to me that masses are attracted to each other. That hasn't been proven yet.
We observe it now. Density,
no, we don't. How do we observe it? Maybe you could explain that to me. How do we observe mass being attracted to mass? How do we observe that?
Density is related to this force called buoyancy. Like, for example, like why do ships float? Right. Buoyancy is a force in the opposite direction. And you're absolutely correct. In a fluid, and we'll call gas a fluid. It's just same thing as a liquid. Just atoms are further apart. The less dense something is, the less it will, or the more it will be susceptible to buoyant forces, which cause it to rise up. For example, clouds, stuff like that. But you don't have to be less dense in order to overcome gravity. For example, an airplane. An airplane is not less dense than air. In fact, that's why they say aircraft is heavier than air. Unlike, let's say, a balloon, a helium balloon.
Right. Are you familiar with the principle that enables that airplane to overcome the so-called gravitation?
Well, yeah. I mean, it comes down all to vectors. Gravitational acceleration has a vector of generally a magnitude of 9.81 meters per second. And we overcome that by generating another force, which we colloquially call lift. If lift is greater than or equal to gravitational acceleration, the airplane either rises or stays in level flight.
Right. Are you familiar with the principle behind lift?
Yes. Yeah. It's in fact, lift is an interesting thing. Even to this day, even though we know how to build airplanes and fly them, and we can do these great things, the exact mechanism which generates lift is still something which is debated and studied.
Well, it's commonly known as the Bernoulli effect, and it has to do with the way air pressure is basically manipulated by the wing combined with the propulsion. Now,
for example, but
hold on, we're diverting now.
No. You brought up a great point, Bernoulli. Great point.
Go ahead.
So of course the idea is, so the theory is, so when a wing goes through the air, the top of the wing is curved versus the bottom is flat. And Bernoulli says, and you can demonstrate this, on a piece of paper, that as the flow of air increases, the pressure decreases. Therefore, since the top of the wing is curved and the bottom is flat, yet the two air flows meet at the same time, the airflow on top of the wing must be going faster. It reduces pressure, and in a sense, the wing is sucked up into the air. Yeah. However, let's consider the wing of an F-16 jet. The cross-section of an F-15 or even an F-18, the top of the wing is symmetrical with the bottom of the wing. So air travels at the same, air travel on the top of the wing and the bottom of the wing travel at the same velocity. Therefore, Bernoulli doesn't apply.
Okay, fair enough. Now,
or a paper airplane. Or a paper airplane.
We're detracting from the topic of the gravitational force. Now, I've asked you numerous times if you can provide me with a demonstration that mass attracts mass. You just keep saying that things fall down, and that's proving that mass attracts mass. But again, you're begging the question of gravity. There's no proof of that. You're saying that mass intrinsically and by a force of nature due to general relativity attracts other mass depending on its density, right? So what I'm asking for is a demonstration of it. I'm asking for proof that mass attracts mass.
But again, you said density. Density is not relevant to gravitational acceleration.
Yeah, you and I can agree on that.
Yeah. So, well, I mean, let's look at it a different way. Instead of trying to prove something and then search for evidence to say, okay, this proves it, let's look at the other way. So we're sitting around, the story goes, Newton goes, well, why does the apple fall? Why does the apple fall? And so now we have to go out and look for evidence to try to explain this. Now, I've heard some say that it's because of electromagnetism, which, okay, if that is true, then objects should be attracted to each other according to the laws of electromagnetism.
All right. So here's the thing. Some do say that, but don't straw man electromagnetism. Did I say electromagnetism?
No. I'm just using it as an example.
Yeah, fair enough.
But so then we go look for evidence. But then when we see that when objects fall towards the Earth, the electromagnetic theory doesn't explain, why they accelerate towards the ground at this set rate, which is, of course, approximately 9.81 meters per second squared. So we got to look for something else. Now, the fact that they fall at 9.81 meters per second squared, you're right, it doesn't actually prove gravity. All it does is like, okay, look, it always falls at this rate. We can take some data, we can graph it and develop an equation, but it doesn't prove anything. I've heard this before, that all we're observing is the effect of gravity, but not gravity itself, which would be a correct statement. Would it be a correct statement to say that there are no experimental proofs of the gravitational force? Well, no, because
Well, I keep asking you for one, and you're yet to provide one.
No, there is an experiment which I've conducted numerous times. I show my students how to do this, called the Cavendish experiment, where you mitigate Earth's gravitational acceleration, and then you can show that two masses will attract each other according to Newton's law of gravity.
So you didn't describe Cavendish.
But that's an experiment which does actually show the effect of gravity.
Well, I know what Cavendish is. I know what the purported experiment is, but what you just explained was not the Cavendish.
I get it wrong. I thought it was Cavendish experiment. The two masses which you hang.
Cavendish, he hung a bunch of things in a barn.
Yeah,
and observed them
they
through
slowly sort of move towards each other. Does it show what actually gravity is, which is how mass curves space-time? No, absolutely not. It does not. Of course, at the time, nobody ever considered that that's the reason for gravity.
All right, man.
Or like orbits, like Kepler's laws of motion. In fact, there's this misconception. When we call something a law in science, it actually, all a law means is it doesn't explain anything. It just shows this always happens. It just always happens. And a law is only disproven by a counterexample. So, for example, Kepler's laws of orbits explain and can make predictions on the orbits. For example, that's why we can predict the upcoming eclipse. But it doesn't explain why objects orbit. All it does is...
So you're purporting that based off what you're saying, that until Kepler, we were not able to predict eclipses. Is that what you're saying?
No. I'm just saying.
No.
Kepler identified.
I thought you just said that. You just said that.
No, I'm saying
because of Kepler's,
how we can predict it, or how we can predict the position of, let's say, Mars in 20 years.
Is it how, or are you just chanting that it's how? Because I mean, I don't know. Some people think that there were very ancient cultures that did quite well with predicting eclipses and other heavenly phenomena without any conception of a Kepler type orbital structure or heliocentricity.
Came up with the equations, which then you plug this in, you plug that in, boom, you get a prediction. But it doesn't explain why things orbit.
It's either that or what happened is they knew what the cycle was, which is basically an 18 to 19 year heavenly cycle.
Mm-hmm.
And basically Kepler just reverse engineered the math based off what was already known. So how does Kepler's, okay, so you just admitted that's true. So then how does Kepler's orbital cycles predict the eclipses when you just admitted that Kepler basically reverse engineered the math off of the known predictions from thousands of years ago? So here's the thing, dude. I don't want to loop about Cavendish experiment and gravity, but let me just ask you: are you really going to stand on Cavendish experiment to say like that's the beginning and end of gravity, man?
No,
So
no, no,
I,
no, absolutely not. Cavendish
I just
experiment.
hold on. We can, here's the thing, man. I'm just constantly fascinated that I find people with my mindset, and we all think differently, but there's a category I could be placed in. I mean, come on, dude. I'm a flat earther. It's quite obvious. And then
Oh, I didn't know
there's
that.
the
I didn't know that.
yeah,
I'm
yeah,
okay
yeah.
with a flat Earth.
And then there's the standard kind of mindset, and I'm completely fascinated in the I don't know, just that there's such the huge dichotomy in between why I think the way I do, trying to understand why you think the way that you do. Just remember this, Nick, when you encounter somebody like me, I used to have the same thoughts, beliefs, understandings as you. And I'll say this for what it's worth. Many times when somebody in your position with your mindset and your understandings interacts with somebody like me, many times that individual will assume that I or somebody like me is just not aware or we're ignorant or uneducated about a matter. And that's usually not the truth. It's not a matter of ignorance on our part. Many times, the person in my role had the same thoughts, understandings, belief systems as you at one point, and then at some point that changed for me. And that's the difference between me and you is you've never accepted my belief system, but I used to accept yours. And you might not be aware that you're existing in a belief system, but I feel as though you completely are, and you are just not in touch with it. So, how would you respond to that?
You know, that's actually a really good point. I assume I can swear a little bit here. I guess asshole is not a swear word, is it?
I mean, YouTube doesn't seem to have a problem with
Okay, so
foul language,
I
dude.
totally agree that, and you know, I see this where I work. I see it among my colleagues. Academia as a ivory tower, and we can be assholes. Some of them are assholes to me because they're like, "Ew, I have more education than you," and we tend to shout down what we just consider stupid. Therein lies the problem. Now, one of the reasons why I also not only work as a physicist, but then also like to teach physics is because I think science does a piss poor job of explaining science to people who don't study science. Um, our science is, at least here in the United States, is 100% dependent upon the general public. You guys pay our bills, whether it comes from tax dollars or whether it comes from private industry. You know, without the money, science doesn't exist. Um, and and as far as it comes to you, I even when I first came on, my intention was not to go, haha, you don't know science, you don't know this. I just thought you had a question about, you know, density, gravity, this and that. I I can clearly see that you have done some research in this because, with probably the exception of some of my students, the majority of this country doesn't even understand that the universe, at least in the standard model, has four fundamental forces. In fact, among flat earthers, you're the first one who has acknowledged that. Um, I disagree that science is um, well, some of the comments you say about science being sort of dogmatic and this, I disagree with that. But I do agree that science can come off as dogmatic. And I also agree that I see this among the people who debate flat Earth. You know, a lot of the people who debate against the flat Earth, they themselves are not physicists. In fact, even though my colleagues totally disagree with this, I really want to start a channel uh, promoting the idea that the Earth is not a globe and using physics as an example to show that we can't just tell the general public, well, gravity exists, and if you don't accept it, it's because you're dumb and stupid and not educated. That's a piss poor way of teaching science. Um,
What do
and
you
I
think
will be
of?
the first to
Yeah,
admit to do science is to admit the first thing I had, you know, when I started as an undergrad, I thought I knew
hold on,
everything.
hold. Hold on,
I
hold
thought I
on.
was
Let
the
me
smartest person in the world. The more science you learn, we don't know anything. We know
hold
shit.
on. What do you know about the horizon? What can you tell me about it?
You mean like when I look out into the ocean and see where the sky meets the earth?
Well, does the sky ever meet the earth? I mean, does that happen?
Well, yeah, I mean the atmosphere touches the earth, but yeah, I get what you're saying. Yeah, the
Do the
horizon.
clouds touch the water?
Well, clouds can. You know, here in
Come on, now, when
where
you're
I live, we get surface fog
right,
coming across the
but we know
ocean.
that the clouds in the sky don't touch the water. The clouds that we see. That's so when I'm
No, I don't
when
know
I'm
that. I don't know that.
you don't know that clouds don't touch the water. Come on.
Even here in my swimming pool, I see condensation which touches the water and
Well,
starts.
that's not a cloud. A cloud is a specific thing. It has a specific definition. That's like you said, it's fog. But the clouds in
It
the sky,
can be fog, but
right? But we know they don't touch the water. Okay. When you look in the distance and you see the train track, right? Doesn't
yes.
it look like it looks like the tracks come together, right?
So not to go off on a tangent. Um, Allegedly, growing up, I had what one would call behavioral problems. I remember that lesson very well in sixth grade, where they taught us again about parallel lines. Parallel lines never meet. That's what they tell us, right?
Right.
And
Train
even in the
track. Yeah.
textbook, and the teacher put up the slide of train tracks. Go look, train tracks are parallel; they never meet. And to make a long story short, at the end of the day, I got sent to the principal's office because I started shouting at the math teacher that you're fracking lying to us because I'm looking at the picture and I can see those train tracks meet.
Right.
And then they also tell us lines of longitude are parallel. Yeah, they clearly meet at the poles.
Well, you just obscured it because you're conjecturing that where we know that parallel lines on a train track don't meet, yet they
Well,
appear to meet, right?
the correct answer is parallel lines on two-dimensional Cartesian coordinates never meet. However, in 3D they do.
Okay.
It's like a triangle in two dimensions,
So,
x and y. The angles equal 180 degrees, but if you project
right.
a triangle on, let's say, a sphere or any
Right.
other sort of
So
three-dimensional
again, what
object,
you did though, you begged the question of globe, you see. So in trying to basically prove globe, you begged the
I'm
question
not trying to prove
because
it wrong.
well, what I'm talking about is the horizon, and I was trying to at least get you to concede the simple, demonstrable fact that the clouds in the sky don't touch the water. But that's you wouldn't concede that, so
I'm
that's
sorry.
why I went
Did,
to
did
train
you,
tracks.
I'm sorry. 25 seconds. Hold on. 1 second. My dog is barking.
I was trying to get him to concede that the sky and the clouds don't ever touch the ocean, but because I'm trying.
Back. Sorry.
Go ahead, Nick.
Sorry.
All right, so
Um,
let's get back to the horizon. We're standing on the
well,
beach. We're at the ocean.
let's
Hold
do
on,
this. Before you talk
man.
about the horizon,
Hold on, dude. Dude,
do
hold
not
on.
assume that I believe the Earth is a
Oh,
globe. Can you do that?
hold on. I know you believe it's a globe,
No,
dude.
no,
Come
no.
on, stop it.
Let's do
Stop
some
it.
time.
Stop it. I know you believe it's a globe. So let's just cut to the chase and get to the convo. Stop this. It's nonsense.
I just know it's not flat.
Okay, then if it's not flat, then it's a globe. Okay, because if it's a globe, if it's not flat and it's not a globe, then come on, dude. Now
It'd be a
you're just
cube.
obfuscating.
No, but I'm saying that's what science is. You think that science says that the Earth is a globe and then goes and sets out to prove that it's a globe. That's not how
No,
it works.
it's not what I
It's
think.
we don't know what the Earth is. Let's
Really,
collect some
because they're
data.
telling us it's a globe and they're telling us they're going to space and they can look at it and they're showing us pictures from the moon missions of a globe. And come on, dude.
Well,
So,
other people have told us that, but let's do it
all right.
for ourselves.
Right.
Let's
Well,
find
that's
the
my
science
point. And
out for
others like me.
ourselves.
All right. So I'm trying to bring you to some place that maybe no one
Okay.
else has
Sorry, I didn't mean
brought
to
up to
interrupt.
you. All right. We're standing on the beach, you and me,
Mhm.
right? We're hanging out. drinking pina coladas, whatever. We're looking out over the ocean and we see a horizon, right? Now, you said it's where the sky meets the water.
Where it
And I
appears.
asked where it appears to. Thank you. That's the word that I wanted. It appears. So the sky appears to meet the water. Now, when we see the boat going out, what's happening to the boat? When we're watching that boat go out away from us, away from the beach, what are we observing?
Well, from experience observing boats leave, it appears to dip below the horizon. In other words, at first I can see the boat from the water line to whatever its highest point is, and then it slowly starts to sink, and eventually I'm unable to see the craft anymore.
Right. And you gave a good explanation based off what you see, except you added something. Right, but you added something that was more of a preconception when you said it dips below, because what you actually seeing is a boat that eventually disappears. The part where the assumption is where one would say that it dips below anything.
You're correct.
For you to say that, I would say that it has to be proven that it's dipping below something. What we're seeing is that the boat eventually disappears.
One of the beginning of science is observation. And so to me, it appears as if, first I see, let's say we're looking at the stern of the boat. I see from the water line to, let's say, a tall radio mast. Then the part which is in the water line, it basically looks as if the boat is sinking into the water as it goes over. Now, this is predicated on my belief that I know the boat is not sinking. And so to me, it appears as if it's going over something. It's going over a ledge, as if somebody was like running to a cliff and then sort of fell off. Like first the feet would disappear, then the knees, then the legs, and then boom, you'd see nothing. But you're right. It is an assumption. I make an assumption. I don't have any scientific evidence. This is merely a visual observation. You're right.
Right. So let me ask you, have you ever maybe laid down really low to the ground on a flat surface and watched somebody maybe walk into the distance?
I've seen people walk into the distance.
Yeah, but have you ever put
whether I'm standing up or lying down, doesn't matter. But
so would it surprise you to find out that if you were to do demonstrations, would it surprise you that if the circumstances are right, you would see people disappear from the bottom up as they're walking away from you on a flat surface?
I have not observed that.
Right. Would you care?
I have observed people go because I will sometimes, let's say, watch airplanes at an air show. They're tiny. They go away. They get obscured.
Right. But what I'm asking is
at a certain distance, I can't see them anymore.
I get that. Would it interest you to know that, that phenomena of things disappearing from the bottom up, even on completely flat surfaces, when they are going off into the horizon, would it surprise you to know that that phenomena is well known, well documented many times? Is that something that you're interested in?
I have not observed it. That would surprise me.
Right. So
I'm not saying it doesn't happen. I'm just saying I have not observed it.
Right. Would you care? Would you care to observe that? Like, does that matter to you? Right. Because you in your assumption and your presupposition was that boat was going.
I'm just explaining what it observes. I'm not saying it actually dips below the horizon or anything like that. I'm just saying what I observe.
Right. When you were describing what is observed, you said below
right now.
Well, I'm inferring an assumption based on your term when you said it goes below the horizon.
That is true. You are inferring my assumption, but
right.
I'm legitimately saying let's forget about the idea of Earth being a globe. Let's investigate what it is. So when you see a ship go over the horizon, it does appear that the bottom starts to disappear, goes down. Now you're saying you can also observe that by somebody walking on a flat surface and going far away. let's do that. Just because I observe that it appears that the ship is going below, all I have right now is a hypothesis. You know, it's falling off the edge. That's my hypothesis. Falling off the edge.
Well, what we can do is if let me just cut to the chase. If one can basically show that when a ship is going into a distance, that it's not going below any water geographical horizon, then one debunks this idea that it's going over a horizon.
I don't know if it's doing that or not. It only appears to be doing that.
Right. It appears to be doing that.
Just what like in a photograph of train tracks, we say they're parallel, but they appear to meet.
They appear to meet, exactly.
Yeah. So what we need to do is explain this phenomenon. Why is this happening? Why is this happening?
Well, some people will just simply explain it due to perspective and the way that we see things.
Yeah, and some people will just say, oh, well, the Earth is round. That's why it's happening. But that's not proof.
Right. So
we need concrete. We need mathematics is what we need.
Well, let me ask you. No, well, we need demonstration. The math is secondary. We need demonstrable evidence. I think that's what we need. Let me ask you another question. What if we were then also standing, and as we see that ship appear to disappear either over or into the horizon, what if we were able to get out some type of telescopic lens, telephoto lens,
to zoom into it? Yeah,
to zoom in. Okay, yeah. And what if that boat then?
I would do.
Right now, what if that boat, after it disappeared from our vision, using telephoto lensing, would be able to bring that boat back into our field of view? What would that say about the boat?
Okay, so let's say I'm at the ocean, I see a boat go away, it's obscured with my Mark I eyeball, my naked eye, right? But then I pull out a set of binoculars, right, which allow me to zoom into the image, and then all of a sudden I see the boat again.
Correct.
Right. Okay. Then that would be an observation. We're like, okay, so that would lead me to the conclusion that, okay, well, the boat isn't actually being obscured by anything. It's just probably due to light scattering that I can no longer see the boat with my eyes. That is perfectly valid. That's what we call experimentation. So let's say
that's my point.
That happens.
So would it surprise you if that's known now to the point where it's kind of common knowledge that phenomenon exists?
Well,
would that surprise you?
Be careful. Now you're throwing in a bunch of, like, as you say, assumptions. You claim that's common knowledge. I don't say it's common knowledge. I'm just zooming into the boat. But what if, as I'm zooming into the boat, I once again see it appear to dip below the horizon?
Which it will at some point. And then what if you then got a more powerful telescopic lens and then it reappeared?
Okay.
And then, but we could both agree that eventually at some point it would disappear.
But our observation shows that, like, for example, I live in California. I cannot see Asia, no matter how powerful of a scope I have.
Right. But we also just came to an agreement. There's a thing called perspective. The train tracks don't meet, but at some point they converge into a point.
How about this? Let's put it a different way. Suppose I'm standing at 5 feet tall and I'm next to somebody who's 6 feet tall. I record. So at t equals 0, the boat starts going away for both of us. Now, at some time, to me, who's 5 feet tall, I witness the boat go below the horizon. But my friend next to me who's 6 feet says, no, that hasn't happened yet. And that happens a few minutes later. How do we explain that? We're both looking through the same atmosphere. We're both looking through the same observation device.
What's simple? He has a higher vantage point.
Has a higher vantage point.
Right. Not because he's able to then see further over some proposed curve. It's just simply due to perspective.
But then without a curve,
when you are higher, hold on. When you are higher in altitude, you can see further due to simple perspective.
What is that simple perspective? You got to define it. Because to me,
perspective is things converge to the relative eye line.
Like
Did you ever take art when you were a kid? Did you ever, if you and I were in an art class and we were trying to draw the boat going out, if we were trying to draw that horizon, if we were trying to draw, say, the train track going off,
I've
we'd
taken
have
art.
to learn certain principles, right? Well, one of the
Full
first principles we
disclosure,
learned,
when it comes to art, drawing is I'm bad at it.
right.
I've taken drafting, which is kind of like art.
Gotcha. So what I'm trying to say to you is, it's most people aren't taught this, and there might be a reason for it. As things that are above your relative eye line, okay, they converge down and towards the center. Things that are below your relative eye line converge up and towards the center into a focal point. This is how our vision works.
True.
This is how perspective works, right? So,
but
based
I don't
on that,
see how that explains why somebody can see further when they're higher up. I don't see that.
Because the way the angular resolution works based on the height. I could pull diagrams and stuff out for you, dude, but I'd just rather have a conversation.
I know diagrams would help. Diagrams would help. I don't know how to do diagrams on StreamYards.
I have them all, but I can pull them up, but maybe we'll do it another time. The point is, you see further when you're at higher altitude, and it has nothing to do with curvature. It has to do with the way we see. It's just simple perspective. Plain and simple.
Well, see, that's where I'm going to run into a problem. Now, I'm not saying the Earth is curved. However, if we just go with the idea that, because we can demonstrate that the higher you are, the further you can see into the distance, a curvature of the Earth makes logical sense. Doesn't mean it happens. It just, that fits the hypothesis. The idea, like, for example, right now I'm looking across the street. My wife is shorter than I am. We both see the house across the street just fine. But as we get further out in the distance, the higher you are, the further you can see. Now, that cannot be explained by, let's say, the inverse square law of light. The light is not getting scattered, but it is a fundamental observational fact that the taller your vantage point is, the further you can see. Does that prove the Earth is ground? No, not yet. But the observation does show us that. So we need to explain why that happens. Now, you say it's
only if you're assuming curvature. See,
no, I'm not
it's begging. The thing is,
the curvature is a good explanation for it. Doesn't mean it's correct.
Right, but once it's debunked, then it's no longer an explanation.
And that's how science works.
Right,
so
exactly.
I think it's curvature. Let's debunk it.
Right. It's very easy to debunk, man. It's very easy, dude.
So let's do it.
All right, let me just do a practical thing.
Okay.
If you went out to let's say a football field that's level, right?
Mm-hmm.
And you put your head really low to the ground and you watched me walk off into the distance, at some point my feet would disappear, okay? And then my knees and then my waist. You would watch that happen.
I've never seen that happen on a football field, but okay.
All right, because you've never tried it. But that's what would happen.
I've been on a football field before. I can clearly see the bottom of the goalpost from one end to the other. So what is a football? 100 yards?
I said if you put your head down to the ground to get the proper perspective, at some point you would watch me start to disappear from the bottom up. My point is, if you raised your head up even a little bit, I would reappear. My feet, my ankles, my knees did not go over some curvature. I'm giving you very simple things that you can do. But here's the thing, Nick. Here's the thing, Nick. Here's the thing.
I'm following what you're saying.
Hold on. If you really cared, you'd probably go out and do the experiments. But I was actually thinking
about doing that, planning a day when we can do it.
My suspicion is most people won't go out and actually put this to the test. All right, let me try to pull some stuff out for you.
No, because the people who wouldn't do it will just go, "You're stupid. You don't know what you're talking about." But I'm all for testing it. In fact, that's my biggest problem with the flat Earth theory. It's let's go test it.
Right. That's what flat earthers have done.
If we have to do the test, let's do it. There's a
Right. That's
football
the
field
point.
very close to my house. Probably it's dark where I assume you're in the US, so it's dark everywhere. But we could absolutely do that test.
Right. All right. Let me bring some stuff. I might be able to show you some stuff. You know, and at least get you kind of thinking in a certain way. If I could find this stuff. Let's talk about perspective first.
Okay.
Have you ever heard of the Burj Khalifa building in Dubai?
Yes. Yes.
All right. So what do you know about it?
I know it's very tall. I believe it's the tallest building on this planet right now. It's got
Right.
30 apartments in it.
All right. So I'm going to bring this up. So do you see the visual about perspective? What I was saying, how things look at his eye line. All right. You see his eye line? They're representing this orthographically, but do you see how the things below his eye line go up and towards the center, and the things above his eye line go down and towards the center, and they converge to a focal point?
No, I assume these lines are parallel, but I'm looking at them on a two-dimensional coordinates, and they appear to be in the distance. Absolutely.
Correct. This is representing the concept of perspective.
Yep.
All right. Now let's play it.
And today, I want to make a quick video. I had a few messages exchanged with a guy on TikTok. He believes that there are two sunsets if you look from the building in Dubai called Burj Khalifa. So we exchanged a few messages.
So it's like you were saying about how the taller guy would see further. It's the same thing here, is that if you're on the ground, you observe the sun setting, and then if you go up to the top of this Burj Khalifa building, the sun reappears.
Correct.
And many people will say that's because of curvature, that the sun has gone over, and now when you go higher, you see over the curvature.
Yes,
right?
that is what people say. I'm not saying that yet. I'm just saying that the observation. For example, right now it's 8 o'clock here on the Pacific time. If I were in an airplane 30,000 feet up, it would appear as if the sun is still out. However, here down at sea level, it's nighttime outside.
Right, but as you were saying before, that's saying, okay, well, it's plausible that it's curvature, because it would make sense.
Curvature is a good hypothesis.
Right. It's a good hypothesis until it's debunked.
That's the whole point. Let's debunk
or until you can show another reason. Because once you show another reason, then you disprove it. Then you could still keep curvature on the table, but now it is no longer a proof.
Yeah.
Can we agree on that?
You would have to show a counterexample.
Correct.
It's Thursday morning here in Japan. Just past 9 o'clock, October 19th, 2023. So here we see the person number one. Suppose that's me. This is my horizon view. The higher I get, the farther I see. There's no curvature necessary in this situation. So the vanishing point for God.
Do you understand? Do you see? Can you see how he's representing it orthographically? This is how perspective is known, where you see his eye line with the first person and you see the second person. Now you could see where based on the first position, that the vanishing point, or where the things above his eye line and the things below his eye line would meet, which is the horizon.
Yeah.
Is at a level that's below the man who is higher, which means that man would be able to see beyond that point, not due to any curvature, but simply due to his perspective from his higher altitude. Just let me continue.
I understand what he's saying, and I would disagree with that. He's incorrect.
What's the disagree?
If it were flat, then the sunset would happen at the exact same time for person one as it would for person two.
But we're showing you, we're showing here that that's actually debunked, because due to perspective, the person at the higher altitude can see further.
Hold on. What we're seeing here is just a graphic. We would have to go out and actually test this.
But we're talking about perspective, and I'm showing you that due to perspective, the idea that one can see further. We're not talking about the sun. We're in a perfectly straight corridor. Picture us in like a huge Amazon warehouse. Have you ever seen those? I've driven by them before. They're monstrous. Now we're in an Amazon warehouse with a perfectly level floor because concrete's level. All right. Concrete lies level. Now we're looking down a corridor in this monster warehouse. This is the experiment based on this picture. What we're showing here is due to simple perspective, the person who is higher will see further. We know the floor is flat. We already have the independent variable, which is the floor versus a straight floor versus a curved floor.
No, I agree.
We're saying that the floor is known straight. Everything is straight. The lines are parallel. We know that. Just like the train track we know is parallel. It doesn't meet. It only appears to converge due to perspective.
Yes. In this, this two-dimensional Cartesian coordinate graph, person one and person two are both looking at what we call a false perspective. It appears to go in the distance. However, observation shows us differently. Person one will see the sunset before person two.
Correct. Person one will see. You and I can both agree on that.
Okay.
But the topic at hand is
we haven't proven the world is flat, though.
Let's continue.
For guy number two is much farther than for the guy number one. The two sunsets effect on Burj Khalifa building in Dubai is due to the fact that the guy on top of the building can see much farther than the guy on the ground. Look at the red line. That's the line of sight of the guy number one. He can see at about half of the square at the end of the tunnel, but the person on top can see beyond that red line, can see much farther away. So let's listen to this guy, and this is his argument, and I exchanged a few messages with him trying to explain, and that's why I'm making this video, so you can understand what's going on here.
Well, one of the things that I very rarely ever see being used to show the shape of the Earth as being spherical is this monstrosity right here, the Burj Khalifa, the tallest building in the world, located in Dubai. The Burj Khalifa is so tall that you can watch a sunset at the bottom, take an elevator up to the top, to the observation decks up there, and watch it set again.
Yep, I would agree with that.
It is so tall that you can watch the sunset multiple times.
We could both agree with that.
Yeah, stupidly tall.
And there is no way for flat earthers to address this, because if the light was receding at a consistent rate, then the entire building should go dark at the same time. But because the Earth is curved, it takes longer because of the altitude that this thing sits at.
So that's the claim. Because the Earth is curved is why the person on the ground will see the sunset before the person at the top.
Correct.
The claim is curvature.
And that's what I would say.
Right. That's the claim. But once you show that there's another option other than curvature for a person to be able to see the sun as it goes further, longer, once you show there's another option, you then can no longer claim curvature.
Well, I don't think this proves flat.
We're not saying flat. We're talking about a very specific thing.
I disagree with the supposition that person. We both agree that person one and person two will see the sunset at different times.
Correct. But we disagree on the cause.
Yeah, this video is not explaining why yet.
It's not done. Let's go.
Okay, let's move on.
To see the sun go beyond the curvature of the Earth.
So he could not be any more wrong than he is. The fact is, the higher up you go, the farther you can see. This is actually a quote by an author from Ghana in Africa. The higher you go, the farther you can see.
What I'm trying to present here to you, man, is that we can both agree that somebody can see further if they are higher in the air. We can both agree on that.
I think we disagree on the reason why.
Of course, but here's the difference. You're claiming that it's due to a curvature. I'm showing you there's another option, which therefore debunks your claim.
Well, okay, not to be pedantic, it's not that I'm just hypothesizing that it's curvature. I think I'm failing to understand why. I don't understand your reason why it happens. That's what I'm failing to understand.
You don't have to understand why. It's just showing that to claim curvature, okay, and then once curvature is disproved,
forget about curvature. Why does person one see the sunset at a different time as person two? That's what I don't understand.
All right, so because if the sun is moving in the sky, right now, still science is going to say that we're the ones that are actually moving, okay, and the sun is relatively still. No, but what we're observing is the sun moving away from us. Could we both agree that that's what we're observing? The sun comes and it moves across the sky and it goes away. That's what we're observing, right?
Yeah, I observe the sun, quote, rise in the east, and I see it, quote, set in the west.
Right. We observe that.
We all do.
Okay. So now somebody like me observes that and I see it. Now, somebody with the moniker of science came along at some point and told me why. They made a claim. The claim is that we're on a globular Earth that's rotating. And the reason that I'm observing this sun move across the sky and go away and quote unquote rise and set is because of a moving Earth. That's the claim, right?
Well, that's another issue. Yeah, we say that as
I'm just asking you if that's the claim from quote unquote science. That's the claim, right? All right.
Which is also supported by, like, for example, the phases of the moon. Like today here, which should be all across.
Okay, you're obfuscating, man. You stick on the subject, dude. We're talking about horizons.
Well, you're talking about why the sun appears to go from one end to another. That's let's go back to the horizon.
Right. We're told, yeah, but because the sun moves, what science would claim is over the horizon. It would move beyond the horizon or over the horizon. Science is claiming that the sun gets blocked by the Earth itself. That's why it goes away, because it's the Earth is then in between us and the sun. Correct? Isn't that what science claims?
I'm sorry. One more. I made the mistake of looking at the chat.
Right. Science is claiming that the sun, quote unquote, sets because it goes over the geographical Earth horizon. Correct? Isn't that the claim of science?
Well, we say that the sun rises in the east and sets in the west because the Earth is rotating, and from our perspective, the sun is stationary. And that's what we say.
Right. And I said science, quote unquote, hashtag science claims that the reason the sun disappears and quote unquote sets is because it is obscured due to the Earth coming in between our view and the sun. Can we agree on that's the claim from science? This is very simple, dude. That's the claim, right?
No, I think you're simplifying the claim a little bit.
Okay, so then how would you conjecture the science claim of a sunset?
Well, we say that the Earth is rotating. How do we say direction in space? Well, if we're looking at a top-down view of the solar system, the Earth is rotating. Hold on, let me get my geography right here. Is moving counterclockwise, so therefore it appears, as let's say the U.S. moves towards facing the sun, it rises in the east, and as it rotates around as it has now, the sun is now starting to set over Hawaii.
Right. So it's basically, yeah, exactly. So it's saying that the Earth is rotating in eastward direction, so the sun moves relatively westwardly. Okay, that's the claim. But at some point for me in New Jersey, based on the claim, after we rotate far enough, the sun, quote unquote, sets based on what science is telling me, because it eventually gets obscured by the Earth curvature. That's the claim, dude. Okay. Can we agree on that claim first?
Well, yeah.
And
I
if,
mean,
and if we can't, then I
yeah,
want you to tell me
absolutely.
why.
If we say that the Earth is just a sphere, we say that it rotates on its axis, and because of that rotation, it appears to us living on the surface that the sun, quote, rises in the east and sets on the west. Yeah.
Right. But why does it's claiming, I'm trying to get you to agree with me about what the claim of science is, or to present another claim, because you seem to be supporting the popular conception of the solar system. Okay. You seem to be supporting the claim that so-called science is giving me. So I'm going to ask you again, can we both agree that based on what popular science tells us, the reason for the sunset is eventually when the Earth rotates enough, the sun then gets obscured behind the geographical Earth?
Yes. Yeah. I'll give you that. That
Okay.
is the scientific consensus.
That's the claim. Right. Yeah. Okay. So we can agree. So we can agree that that's the claim. So my point
You call
is,
it claim, I call it consensus, but yes.
all right. So now, once they present that claim, then the burden is to prove the claim. Okay. Now, people will say the proof, one of the proofs of the spinning, rotating Earth is that the sun sets and it goes below the horizon. Like you said, the boat below the horizon, the sun below the horizon. It's the same thing. It's an object going below a geographical
I
horizon.
wouldn't say that's proof, but the Earth being a rotating sphere is a way to explain that phenomena.
Correct. And that's the way that the science, so-called science, explains it. Correct. What I'm trying to elucidate, okay, is that hold on. Once we can give another explanation for why things disappear into the horizon, whether it be a boat or whether it be a sun, once we can give an alternative explanation, it is then no proof at all.
Absolutely. Absolutely.
Okay, well, that's the whole point of this conversation. So if I can give you another explanation, like the man did when he was explaining perspective and saying there's a reason that once the sun, quote unquote, disappears from our view, if you go higher, you can see it. There's another explanation other than Earth curve. Let me play this. Let me play something else. Let me continue with this. We're talking about perspective here. And we're talking about the horizon and why things disappear. Mm-hmm. All right. Are you looking at the screen?
Yeah, I'm looking at that screen.
All right. What do you see here? What are we looking at here?
I see a bicyclist in what looks like a 10 speed going over what appears to be a bridge.
Right. So he's on a road of some sort, whether it's a bridge or whatever it is. Okay. We're going to watch him as he moves away from us. All right. And let's just observe what we see.
To be going down a curve, when in fact we can see that his feet and wheels are.
All right. So what's happening to the image of this guy on a bike? What are you noticing first?
I see distortion from heat coming off the bridge.
Don't assume things. Just tell us what you see. You could assume it's heat. We don't know. It could be. I know he's in shorts. It could be 0 degrees, man. We don't know what the temperature is.
Well, if we want to talk about convection, that's a whole different story. But
no, I don't. Oh, I don't. We can, but we're talking about what we see
due to heat. What else?
No, you just told me what it's due to. I'm asking you what you see, and you keep presupposing what you see. But I'm asking you what you see right now in this image.
I see a distorted image of a bridge and a bicyclist over it with a purple line right under his butt.
As he's moving away from us, right? Notice the ground
right now because you're not playing the video.
All right, go ahead.
Okay.
All right, he's continuing to. Yep. Do you notice there's a mirroring effect that's happening as he's moving into the distance? Do you see the mirroring effect?
I do.
All right, you see how he's down there? Now, we no longer see his feet at all. We no longer see even his legs. We just see his torso.
No, it's a very distorted image due to heat.
You keep saying it's due to heat. It may be due to heat, dude. But what are we watching? Doesn't the world have heat?
We're watching a bicyclist go over. It's a bridge, right? It appears to be a bridge.
Right. And what we're watching is his lower portion of his body is disappearing from our view. That's what we're watching. Right? Okay. It's disappearing from our view. It was there and it's no longer there. And the further he moves away, the more the lower part of his body is disappearing.
Okay.
All right. Are you still watching?
Still watching.
All right. He's still moving into the distance.
Yep.
Okay. Now, all of a sudden, we can almost barely see him. He's disappearing from the bottom up. There he goes.
I wouldn't say I can barely see him, but I see him. Yeah.
Hold on. Now, would you say you could barely see him?
To the right.
And you could barely see him, right?
Yep.
Okay, so we watched an object moving into the distance, disappearing from the bottom up, and eventually, as you see now, he's gone. We can no longer see him. He's no longer in our field of view. Can you and I both agree that we just watched an object move into the distance and disappear from the bottom up to a point where we can no longer see him? Can you and I both agree on that?
I would agree with you and I both watched the same video.
Okay. And so we can agree that we just observed the same phenomenon. Now, let's talk about the ground that the object was on. The ground it was on was flat. Would you contend that we just watched him disappear over some type of physical curve? Is that what we watched?
I'm sorry, say the question again.
Did we just watch that object disappear because it went over a physical curve, thus being obscured by physical Earth?
I think the better question you want to ask me is, why did it happen? You can't tell me.
No, I'm asking you the first question. I asked you a question. I'm not telling you anything.
Why did it happen?
I'm asking you, do you think we watched him disappear because of a curved road?
The bridge does appear to be parabolic.
Okay, so
most bridges are parabolic.
So you're telling me you just watched that and you're positing that the reason we watched him disappear from the bottom up was because of a curved road.
No, I'm saying the bridge is parabolic. Most bridges are.
Right, which would mean the road's curved.
No, you can have a parabolic bridge on a flat surface.
Okay, so I'm asking you, do you believe, honestly, that you just watched him? I'll rewind it. Do you believe that we're watching him disappear from the bottom up? Does that look like the reason he's starting to disappear is because of a curve?
Even before he disappears, the bridge itself appears to be parabolic because I can't see the edge of the bridge. From a purely mechanical engineering point of view, most bridges are parabolic. They're not perfectly flat.
Okay, but that's not what I'm asking you. I'm asking you.
No, you're asking why he appears to disappear.
No, I'm asking you a very pointed question.
The surface which he's driving over is parabolic, which means it's curved.
Okay, so okay, but see his torso and up to his on his bike is probably 4 feet in the air. So do you think that there's 4 feet of curvature that obscured his body? So here's my point. Nick. We're obviously watching him move off into the distance, and he's obviously becoming obscured from the bottom up due to perspective, miraging, refraction, and lensing. You and I are both watching it. Hold on.
That's a
Hold
different
on.
effect.
I'm watching the mirror aspect right here. I'm
Uh-huh.
watching the miraging effect happen. You can see the pink on the bottom. This is an obvious mirage. So here's my thing, Nick. You and I both watched him move off into the distance. We watched him disappear due to perspective miraging, lensing, and refraction. But you are going to try to claim that he actually went over. Well, I asked you if you believe that he disappeared because of a curved road, and you keep saying yes.
I believe that the bridge he's going over is in fact of a parabolic shape and it's curved. I do believe that.
You're not being genuine. I'm asking you if you believe
I'm telling you exactly what I
I'm
believe.
asking you if you think he disappeared because of said curve of the road that you're espousing without evidence.
Keep playing. Let's see why he disappears exactly.
Well, you're busy typing like a secretary.
I know. Never read the chat while you're on the panel. I can't help myself. But
I don't think you're interested
I want to see
in
how
the
he disappears
truth.
into the trees. I remember him going off to the right. I see the mirage effect. No, keep playing. Just start from right there. Let's watch it. You got my undivided attention. Okay. We see the mirage building on the bottom. Okay.
We can see the miraging, the lensing, and the mirroring.
We see the flat line.
Right. All right. So my first question is
for a second though. The flat line itself is not. We can't actually use that as perspective because you can clearly see the cameras moving. So I'm ignoring the purple line. But continue. You should have used a tripod or something.
Okay.
Okay.
We're watching him disappear from the bottom up.
Yep.
Okay, now we're looking at a lensing. So if you were to claim, if you're to claim that is a curved road, why can we see the lensing effect here? Wouldn't that also be obscured?
Okay, I don't understand. Do you deny that the bridge is curved?
I'm denying that he's disappearing over a curve, even if there is a 6-inch curve. We don't know what the bridge is curved. Look, the bridge is flat enough.
What bridge is this?
The bridge is flat enough for this experiment. I could bring up other things, dude.
Okay,
you're focused on the bridge.
Hold on. Can you just
so your argument is that the bridge is
play
curved.
The video. Play the video from the beginning. I'm not going to look at the chat. Let's just look at the video. Don't stop.
Oh my god, dude, you are insufferable,
Can you go back?
man.
No, go back.
I don't have to go back. We're watching a man go off.
No, I want to see the whole thing.
Let me ask you: if the bridge is curved, why do we still see the guardrails in the distance?
Complete video. Play the whole thing.
All right, now we're going to another one, dude. You're insufferable, man.
No, I'm trying to be.
This is the part. See, this is where I always get with people with your mindset. You show yourself to be disingenuous, Nick.
The whole video? Why would you? Okay,
it's literally playing as we're watching it.
Tell you what, continue. I'm just going to look up the video myself. I'll watch.
Just watch the video, dude.
I know. I'm asking you to play the whole thing from the beginning to the end, or at least.
All right. I guess we're not watching the same thing, dude. I guess we're not watching the same thing. All right. So as we just watched somebody, obviously, as we just watched somebody obviously go off into the distance.
Show me the video.
You're disingenuous, Nick, and now you're just showing yourself.
You have no idea. I am trying to be as genuine as I can be. Let's just watch the video from. When it starts,
Nick, we just watched it 3 times. You're insane.
I want to see it again. That's science. Let's look at it again.
We just watched it. It's 1 minute. You can't even pay attention for a minute, Nick.
Go. Okay. So what I saw is a biker go across. I saw a mirage develop, and I did see him sort of disappear. What appears to be the horizon. Absolutely.
All right. So I'm asking you again, very pointedly. Do you conjecture that the reason we watched him disappear was because of a physical obstruction due to the road curvature?
If you could go back,
come on, man, you could just say no and we can move on. It doesn't mean you're conceding to the flat earth. If you just concede to the obvious point that's making you look more disingenuous than I even thought you possibly could be, you could just say, no, I don't think it was the road, because it's obviously not, dude.
Well,
come on, man. Come on, Nick.
I want to analyze it.
Come on, Nick. See, this is where I always get with you people, man.
Okay.
Because you show yourself to be disingenuous because you want to be right more than truthful. So I'm not angry. I'm not angry.
Why won't you let me? Why won't you let me actually analyze
you want to be? Here's the thing. You want to be
right.
You want to be right more than the truth. We just analyzed it. We just analyzed it way longer than we should have.
I don't want to be right or wrong. I want to analyze the video.
If you were interested in truth, you would concede.
I am interested in truth.
The
beginning of science.
Nick, you would obviously concede.
No, I wouldn't.
That it was not due to the road physical blockage of road curvature.
Okay, that's your claim.
Why we watched an entire bicyclist whose head is probably five feet off the ground.
Why do we see him right now? Why do we see him right now? That's why I wanted you to go back. He disappeared. Go back a little bit. He disappeared, but then all of a sudden the camera raised its perspective and we see him.
Right. The camera went higher and we see him. That's the whole point that we started with. The camera went higher and we see him. It's not due to road curvature.
Okay, then
that's the point. That's the whole point I'm trying to make to you, dude.
What is it due to?
What's the P word that I've been trying to say to you consistently?
Okay,
right. Remember the image I showed you about the guy. Do you remember the image that I showed you about the man in the Amazon store that I said, look, let's picture ourselves in a big warehouse and look.
I think you and I are on different pages. You want to prove the world is flat.
No, I'm trying to show you demonstrable reality. I'm trying to show you reality.
Yeah,
that's all. I'm showing you, right? And you consistently tried to defend. I
haven't tried to do anything.
You tried to say that the road is curved. Look, he raised the camera.
Yes,
does that look like a curved bridge to you?
I do believe the bridge is curved.
Right. You believe that bridge is curved 5 feet? He's obviously showing a flat bridge.
This is a bad video. Let's look at a flat road.
I'm trying to find things that are completely flat, but my point is you'll probably never concede, dude.
No, I will.
You won't even concede this obvious demonstrable point. I'm not asking you to say, I'm a flat earther.
That's where you fail. This is not a matter of conceding or this. This is a matter of looking at evidence and see where it leads.
And that's what we're doing, but you appear to have a mental blockage. It's not winning. It's about a true thing versus a false thing.
You're just explaining this phenomenon.
I'm bringing you into a space. I'm showing you that the reason things can disappear into the distance is not necessarily because they're going over a curvature. Because hold on, Nick. I just showed you a demonstrably flat road, or at least flat enough for our purposes.
We have not established that it's a flat road.
Oh, really? So you're going to stick to the fact that you're going to claim that the reason we watched him disappear is because he went over the road curvature.
I'm going to stick to the claim that the bridge is parabolic.
You're disingenuous.
Find a video of flat road. Find a video of flat road.
You are completely disingenuous right now, dude.
How so? Are you saying the bridge is not parabolic?
I'm saying we're looking at an obviously flat road, relatively speaking, given
obviously. Notice I'm not.
It's obviously flat. It's obviously flat.
Looking at evidence.
It's obviously flat. We watched an object. We watched a 5-foot high object completely disappear as it moved off into a miraging, refracting horizon. And you have the unmitigated gall to try to claim that it's because the road is curved. You know that's disingenuous. You know it's disingenuous. You just don't like what you're seeing, Nick. That's the problem.
I think you don't like what I'm saying.
No, you don't like what you're seeing, so you're lying to everybody on record.
So here's the problem. This is why your side fails, because
my side?
Yeah, because you're unable to have actually a scientific discussion about this.
Really? I'm the one who's bringing up oh, really?
So all you're doing is basically, I'm right because
I have not. No, I'm sure.
That's your proof.
Here's the ironic thing, Nick. I have not ad homed Nick. I have not ad homed you yet. I have not straw manned you. And as I'm bringing up
the argument,
hold on. As I'm bringing up demonstrations, you're actually denying what you're seeing in a disingenuous way.
I'll give you this. Out of all the people who have tried to debate me, you're knowledgeable about your topic, and I like that.
I'm knowledgeable about the truth.
I don't know why he disappears. You tell me. I don't know why he disappears.
Here's the thing. Neither of us have to know why, but we can debunk that it was road curvature because it obviously
fine. Let's
is
say it's
not.
because, okay, fine. It's not a road curvature. Then why is he? Then why?
After that is another topic.
That's
just
the important part. Remember, I said the reason I study
the important part is to debunk
because I need
the
to know
important
why.
part. Yes, the important part is to debunk your preconception of curvature because you have a belief that things disappear due to curvature, and I'm debunking it.
That's my hypothesis.
I'm debunking it. I'm debunking your hypothesis.
I don't believe you've debunked it, but I will accept if it's not curvature, then why?
Look, just because I can falsify a claim, I am under no logical obligation to supply another claim. You should know that, my friend. Nick, no, you should know that. Nick, you need a lesson in logic. Nick, you need a lesson in logic.
I know quite
a bit. Because once I debunk a claim, I am under no obligation. So once I can show you another reason for him disappearing into the distance, I am under no obligation to give you, another bullshit theory. It's enough to say that we can prove that due to perspective, people at higher altitude, or when somebody has a higher vantage point, they will see further on a flat surface, plain and simple.
We both agree on that.
You didn't agree on that before. I had to convince you of that because you were trying to tell me that the reason that somebody can see further. Perspective, dude. This is demonstrable. This is the way we see.
An adjective. What causes that perspective? Why? And you just told me it doesn't matter why.
You're telling me
that the world is not round. Fine.
Because I can keep going,
but that's not satisfying to me. I want to know why. Why?
Because I could debunk your theory of things disappearing due to convexity.
Show me the truth.
That's science. That's what science is. You're showing yourself to be disingenuous. You're showing yourself to be disingenuous.
Are you admitting that you don't know why he disappears?
I'm saying he disappeared because of perspective.
Okay. Perspective. What is that?
It's the way we see. That's why.
Is perspective an objective phenomena or a subjective phenomena?
It's a demonstrable phenomena that we all observe every single day. Okay. It's demonstrated.
So
it's optics, man. It's how we see. It's not the world. Do you understand? Perspective is not the world. It's our perception of the world. Get it?
Okay. Our perception of the world is subjective.
Right. Just like it's subjective when we see the sun go off below the horizon and boats go below the horizon.
So
it's subjective. It's how we see it.
So the reason why we know the world is flat.
Straw man. No, what I'm showing you is the explanation that you give of convexity is debunked due to obvious perspective.
What does convexity mean?
Curvature.
Okay.
You think boats disappear into the horizon because of curvature. You think the sun sets over the horizon. Hold on. Right. That's your hypothesis.
You got to be correct. I didn't say I think that. That's my hypothesis.
Listen, man, you're obviously being disingenuous. You understand that, right? Do you know that about yourself at this point? Do you know that you're showing yourself to be completely anti-scientific and actually clinging to your religious belief in pseudoscience? You understand
I would disagree with that statement, but you're welcome to your belief.
Yeah, like you get that, right?
No, you're welcome to your belief. I respect it. I respect it. I mean, what do you want me to say? Agree with you? That would be being disingenuous because I don't agree with you.
No, what I want you to do is I want you to admit that we watched the bicycle disappear not due to the road blocking him.
If I
That's what I
said
want you
that,
to say.
I would be being disingenuous.
Oh, really? So so you believe that the reason that we no longer saw the bicyclist in the distance is because the road was blocking him.
I believe the reason we didn't see him, yes, because the road is parabolic and we could no longer see him. And let me finish. The reason why, when the camera was raised to a higher altitude, we were able to once again see him, which does support my hypothesis. Yes, absolutely. I agree with that. Why are you
Right.
getting
Okay.
angry
So
with me?
again, so
That's
after
my
all
belief.
this, you just finally admitted that you believe that it was the road that blocked
Yes.
him, and that's why he went
Yes,
away.
that's my
All right.
hypothesis.
Hold on. I'm going to pull another one up. I'm going to play
You and
some
I both
music.
agree with this. Why
Hold
are we
on.
arguing about this?
No, we don't, because you think he disappeared because of the road, and I'm
I
telling you, it had
believe he
nothing to do with
disappeared
the
because of the
road.
road.
Right. So that's
Yeah.
why we're arguing about it, because we don't
Okay.
agree.
Show me otherwise.
Are you short circuiting, Nick? Or are you just lying at this point? Please answer that.
That's your response? Because it seems like when we actually, when we actually talk about real logical things, that you just have to resort to saying, "Oh, are you
I
lying?" or
don't
this.
believe that you believe
I
that
think
the
you're in a
road is the
feedback loop.
reason.
I
Nick,
think
I
you're
don't
confused.
actually believe you
I
think it
think
was the
you've been
road.
parroting stuff that you heard on the
Nick,
internet
you're
and can't
Nick,
actually think for yourself.
Nick, no, I'm actually destroying you right now, and you can't take it.
If that's what you want to believe,
Hold on,
that's
I'm going to
fine.
play some music, and I'm going to bring up another example. Hold on, please, everybody.
Please do.
Yeah, thank you for hanging in there. Much
If
love.
you knew me on the internet, you would know that I admit when I'm wrong.
No,
It
because
doesn't
if you
take
did, you
time.
would have admitted that it obviously wasn't road curvature. Everybody could see that it wasn't the road, dude. That shows you're
No, everybody
disingenuous.
can't see that because I don't.
You
see
should
it.
have conceded the point and moved on, because you lost right there by
like
being
Pink Floyd?
obviously
You like Pink Floyd?
disingenuous, dude. By
You
being
like Pink
obviously
Floyd?
disingenuous. All right, so I want to show you another demonstration. All right, let's get into it. All right, do you see this?
Yeah, I
Nick,
see what's on the screen.
so he's basically got a camera that he's lowering down towards the water surface level. Okay. Right.
Yeah.
Being about a half inch above the water. This is zoomed in. You can see the white piece of debris by the bench to the lower left of the bench.
Do you see the white debris over here by the bench?
I'm sorry. No, where?
Do you see my cursor?
Okay. Yeah. Is that a white bench next there, sort of
Across
towards
the
the
way.
right? Okay. Yep. I see
There's a
it.
bench here. So we're looking at a piece of white something, just debris on the edge on the shore there. All right.
So you'll see there, it's gone, and I haven't even touched the water yet. There.
Okay. So he's showing that he dropped it down up towards the water surface, and the debris disappeared. Okay, you can do this yourself, Nick. I can do it. Okay, this is a known phenomenon.
Yep.
It's like I was saying about the football field, but instead of the football field, it's a lake. Got it?
We're gonna try that, by the way.
All right. So again, he brought it down and it disappeared. He did not submerge the camera lens below the water, but yet the object that was clearly visible above the water disappeared. Okay.
May I say it one more time?
Well, there's more of it, but yeah, I could show it again.
Yeah, just.
So I'm lowering my iPhone from.
So before you play, just point.
Just
I see the bench and point to exactly what it is we're looking at.
It's not there yet. Hold on.
That's just when the casing on the iPhone just barely touches the water. Right there. So the camera is inverted. It ends up being about a half inch above the water.
All right, so he's demonstrating when he brings his camera down, he gets the lens to like a half inch above the water. All right. I hear you typing, dude. Do you see the white object?
Yep, I see it.
Where my arrow is pointing? Okay.
Yep, absolutely.
It's can you and I both agree that that white object is above the water and it's on the edge of the shoreline? Okay.
Yep.
Now watch. He's going to drop the camera.
You can see the white piece.
He's zoomed in. Okay.
Okay.
Debris by the bench to the lower left of the bench, across the way. So you'll see there.
And it disappeared. Did you see it disappear? It's no longer there, right? What?
Wait, I'm sorry. I'm looking at the stream.
Did you have a really short attention
No.
span?
I see it disappeared. Yep.
I'll do it again.
No, I saw it
above
disappear.
the
I saw it
water.
disappear.
This is zoomed
Let's
in.
watch it.
can see the
You
white
can literally
cube
watch it as
by the
it
bench
goes
to the
away, as
lower
it
left of the
disappears
bench.
from
Yeah,
view.
I'm sorry.
You can
Let me
watch
look
it
at the
that way.
StreamYard
the way.
stream because that's in real time.
Can you see my cursor when I'm on there?
Yep.
Like, is
Yep.
it,
I see your
all right.
I see your mouse moving around. It's just
All
a
right.
little bit left. Yep. Now you're pointing at the white dot.
It's right there. Just watch it. And it takes a couple seconds. I just want you to focus
Mhm.
on it.
You'll see there.
It's gone.
Gone.
Now it's
and
gone.
I haven't even-
It disappeared. Now.
Yep.
He didn't bring it below the water. So what I'm asking you is, can you and I agree that it's not the water that's blocking the object from our field of view? It's just disappeared because of the way we're seeing it. Can you and I just agree with that?
No, I believe it is the water which is actually blocking the view.
So you think the water is curved over a lake enough to block that?
Well, if the lake is big enough, yeah.
All right. Does this lake look big enough to obscure an object?
I can't really tell. What lake is this? Where is it?
So what does it matter where the lake is? Does that matter?
Well, it does matter how big it is. I mean,
he just showed you this. I'll show you the non-zoom part. This is it. This is what it looks like, not zoomed in. It's just a regular lake.
it doesn't look that big. I'll give you that. It doesn't look.
All right. So
I'll
again, I'm going to ask you, do you think that the reason that object disappeared is because it was blocked by the curve of the water?
I believe it was blocked by the water,
which would have to be curving in some way for it to disappear. So the
curving would be my first hypothesis. Yes.
So you're saying that your hypothesis on why that disappeared is because the water is curving. So the obviously level water that's showing a specular reflection, which implies level water because water's level always. You're implying the reason it disappeared because because the water was obscuring it.
Yes.
Okay. All right.
Water is not always level. I mean, sea level is not constant.
Right. So do you know
at this scale? Yes, the water is level. I agree.
Right. At this scale is the water level.
It's not parabolic like the bridge. I totally agree.
So that's why I brought this up. That's why I had to play Pink Floyd to fucking find this, because you kept arguing about the parabolic bridge. So now you just argue parabolic water though, dude. So now I showed you water and you argued parabolic water.
Yeah, water can be parabolic.
But you're positing that this water's parabolic. Correct?
No, all I'm saying is that the white dot there appears to be obscured by the water.
Or it just appears to be obscured. You see, you're assuming water. You're presupposing the water. See, what happens is I just showed you the object disappearing on an obviously level surface, which is water, which is the most level thing there could be. All right.
Yep. Water is a good thing to level stuff with.
Right. It really is. Right. So, but then you still are sticking to your hypothesis.
No, all I'm saying, I'm not. All I'm saying is that dot, as he lowered the camera, appeared to be obscured by the water. That's all I'm saying.
No,
I'm not making any conclusions about it. I'm just saying, yeah.
No, you're concluding that you're concluding that.
Do you see the white dot anymore?
No, I don't see the white dot.
No, and I don't see the white dot anymore.
Right, but you're assuming the only reason it could disappear from our view is the water. You just claimed. Do I have to rewind? You just claimed that it was water.
Let's see it again.
We don't have to see it again. We saw it. It disappeared.
Yeah, and to me, it looks like it's being obscured by the water.
Okay.
I don't understand the debate.
Did he? You don't understand the debate. So did he dip his camera? Did the lens go into the water?
I don't know what he did.
But you don't know.
It appears to be obscured by the water.
You obviously saw that his camera lens did not go.
So then why is it obscured?
That's the whole point, Mr. Nick. You're
Yes, I agree with you.
I don't know. Or your disingenuous nature.
That's the point. What I saw, it appears to be obscured by the water, but I don't know what it's obscuring.
How? So let's. Okay. So if it appears, if the water was
obscuring, why do you assume that because it appears
that means the water over this lake would have to be curved like an inch? You're saying this water's curved over this
I'm
lake.
not saying that. I'm saying it appears to be obscured by the water. One of the explanations could be that there's enough distance that the curvature of the Earth is relevant.
It doesn't appear to be obscured by the water. It appears to be obscured, and you're positing water curvature over a lake.
I like it. Okay.
That's what you just posited.
No, all I'm saying is it appears to be obscured the water. What do you think is obscuring?
No, it appears to be. Okay, let's just continue the video. All you and I could both agree on is that when he brought his field of view low enough above the flat level surface water, an object that was above the water disappeared from our vision. That's all we know. You're the one that's positing curved water on a lake.
It appears to be obscured by the water. My guess is,
how does it appear to be obscured by the water? It just
because I see it in one frame, and then in the second frame, it's gone.
Right. So you are assuming the water is blocking it when you know in reality
I'm not assuming
the water
that
is level. You just said, right. You're
what do you want me
assuming
to say?
a reason.
I mean, do you want me to say I still see it?
No.
In one frame it's there, in another frame it's gone.
Right.
I don't know what you're asking me.
So let me ask you, at this point, Nick, I'm just assuming they're paying you to come on here and do this.
Oh, come on. So we
Nick,
can't have a real
because
debate.
That's what because Nick, your level of disingenuousness
so you want me to lie?
So
you want
off
me to
the
tell you
charts.
that I still see it? Come on, why are you getting so frustrated?
Now I'm just going to actually challenge your intelligence, Nick. Honestly,
please do.
I'm going to have to soon, because what I'm saying is you and I both watched this. Nick, you and I both watched this object disappear. All right. You're the one who is assuming it's the water.
I'm not assuming anything. Do you not understand?
Okay.
To me,
I'm listening to everything you're saying.
It appears that it is being obscured by the water.
Right,
I'm not saying it is. I'm just saying it appears to be.
Based on
just
what?
Like the reflection of the water appears to show a tree.
Based on what evidence do you conjecture that it appears to be the water? What is giving you that evidence?
Play it again and I'll show you.
Are you insane to play it again? What are you going to see different? What are you going to see that's going to make that water magically bend? What am I going to be able to show
the water's bending? I'm just saying it appears to be.
I'm so glad you came on, Nick, because you are showing not only to me, but my entire audience, the level that your argument is coming from.
For the most part, you've been fairly respectful and seem like you actually want to have
fairly respectful. Nick, at this point, I'm challenging how genuine you're being in this conversation.
I'm saying it appears to be. I mean, how many times do I have to say it? To me, it appears that it's being obscured by the water.
Based on what?
I'm not saying that it is being
based
obscured
on
by the
what?
water.
Stop. Based on
my
what?
eyesight.
Based off your belief that water is curving.
Okay, so maybe I'm seeing something different. You tell me why it's obscured.
I'm going to do it again, Nick.
Okay, so there's a white dot.
The white piece of
I see. There's the dot.
Bench to the lower left of the bench.
Okay.
Across the
now
way.
He's going to move the camera down, right?
So you'll see
down. Boom. Stop.
And I haven't even touched the water yet.
It disappeared, right? We no longer see it. It's gone from our view, right? We can't see it.
I can't see it.
Right.
Can't see it.
Okay. Now, there's a number of reasons why we can't see it. But I'm going to tell you for a fact, one of those reasons is not because level water is blocking it.
Yeah, I'm not saying that's the reason why.
Okay, then how is the level water then blocking it?
I never said it was. I'm just saying, to me, it appears that's the case.
Okay, based off what? Why does it appear to you that the water is blocking it, other than your belief?
Because it looks like the water is blocking it. I don't understand your question.
It doesn't look like the water is blocking. I'm asking.
Okay, so then what is?
How could? That's the question, and that's what I'm going to proceed with.
Okay, so what is blocking
But
it?
I'm really trying to get you
Do
to
you want me to be
understand.
honest with you, or do you want me to lie to you?
No, I want you to be honest with yourself, because you're
I'm being
basically
honest
tell
with myself.
yourself
To
that
me, it appears
level
the
water
water is
can
blocked.
block something.
How many times do I have to say that?
All right. So, okay. But the fact that you
Are
can't
you
see
unable
the
to accept the
contradiction,
fact that
the fact that you can't
maybe my
see the
eyesight
mental
tells me
contradiction that you're making, Nick,
I'm not
astounds
making any
me.
contradictions.
It's a mental because how could a level
I
water
don't
on
know.
a lake
I have no
block
idea.
something?
I don't know.
Exactly, because the answer is it can't. The answer
Okay.
is level water can't block anything.
Okay.
That's
So
the
it
answer
can't.
that you just
Yet,
that
I
you're
still see it.
funny, that you're
So maybe it's
religious.
an optical illusion. It's an illusion.
Oh, now we're getting somewhere, Nick. Now we're getting somewhere. It's disappearing due to an illusory reason. Yes,
I don't understand.
exactly.
I'm telling you the truth, what I see. And to
No,
me,
you're not.
it
You're,
appears
what you
that it's being
see,
blocked by the water. I never said
appears.
it was being blocked by the water. I'm saying it appears to be.
Okay. All right. So let's take it. So it appears to you to be blocked by the water. So now I'm asking
Then you
you,
want to jump to the conclusion
because
that,
you want
it's
to.
'cause the
No,
water's
you're the
pure.
one jumping to the conclusion, because here's the
No,
thing,
you
dude.
are. You're
I'm
telling me
I'm going to ask you this. How can level water block anything?
What do you mean?
How is it possible for level water to block anything that's above it? So if I have, hold on, time out, I'll let you go. If I have an object that is above the level water, and my field of view is above the level water, then how could the level water ever block the object from my field of view?
If it were level water, and let's say the surface also was flat, then yeah, you're right. It shouldn't, the water shouldn't block it.
It's not that it shouldn't, it can't. Level water can't block two objects above it.
Fine, whatever.
Right. So if I have a field of view above level water, it can't, not shouldn't. It can't.
Okay. So then what's blocking it?
Okay. So you said some illusory thing. What I'm trying to show you is things can disappear from your field of view due to other reasons than physical obscurity. Do you understand?
Absolutely.
I'm showing to you that it's impossible for the water to block the object, but yes, it still disappeared from our field of view. All right, let's just continue, okay? Please. So again, this is showing basically what I showed you before about perspective. Yep. Okay, do you see it? There's a 50 right at the eye line. There's 50% of your field of view is above your eye line and 50% is below. This is how perspective works. This is the same thing I showed you before. All right. Now, it says, so the distance to the vanishing point is dependent upon the observer height, because the proximity to a tangible surface, like a floor, will limit the angles with which distant images are formed. As the angle diminishes and information is compressed, the vanishing point is brought nearer to the observer. So what he's showing here on this bottom image is, as you go closer to the floor, which at this point they're calling the tangible surface, all right, you watch that the vanishing point is brought nearer to the observer, meaning the vanishing point is closer. If you go higher, you see further. Let me continue. All right, what do you see here? Do you see this corridor here?
Yeah, I see it.
All right, you see it's multiple pictures?
Example. Good example.
All right, so we're looking down a hallway, okay? Now, you can see that in each sequential and consecutive picture, he's dropping his field of view. He's getting lower to the ground, all right? You see this first one where my cursor is. He has 7 feet below his eye line and 1 foot above it. You get it? So let's call it an 8-foot ceiling. Right? Do you see what the perspective's happening? Yep. Then he has one where it's down a little bit and you can see the perspective. Then he drops it more. And then in this last one, he's 1 foot above the floor. Do you see the perspective of that?
Yep. I see that.
All right. And up here, he even did more. He went from 8 feet to 7 feet, all the way down to 1 foot. All right. So he's there. And then he has golf balls spaced below the lights, which are 10 feet apart. So what he then did was he went down the hallway and he put golf balls on the floor. Okay. Do you understand it? Do you understand the demonstration that he's?
Yeah, no, I see what he's doing.
All right. So we're looking down a hallway
Actually,
and we
a good
have
experiment.
and we have golf balls spaced 10 feet apart. That we know that. We can measure the hallway. We know that as we look in the hallway, it looks like it comes together to a vanishing point. But we know in reality, because we could walk down that hallway, that those walls never touch. The ceiling never touches the floor. It only appears to do so because of perspective. And this is what I keep trying to impart to people who defend certain positions regarding the globe, is that people confuse perspective with demonstrable reality. All right. So
Yeah,
let me
continue.
All right. So all right. So he's still showing it. It's the same thing. He's demonstrating how your visual field gets compressed as you go down.
And you know what I like to say is I like the fact that these people are actually doing experiments, and these are totally legitimate questions. And that's where I think science fails, is they sort of dismiss these experiments going, oh, you're stupid, you don't know what you're doing. But these are legitimate questions. Most of us believe what we see, and yeah, science has to explain it.
Now we're at secondary to small obstructions within perspective. So
Science,
okay, now let's look at the golf balls. I want you to see how he's on the floor. All right, now what he's showing here is those same golf balls. As we go down, you can see the one closest here where my arrow is. As it proceeds down, we watch the golf balls appear to get smaller because their angular size is being reduced due to their distance. Okay, now they eventually disappear. If you notice, the golf ball all the way at the end is half occluded. All right, and it's disappearing from the bottom up. Now I'm going to ask you, do you think that the floor is curved? So we're going to go back to this curved thing. So is the ball disappearing because of the curved floor, or is the ball disappearing because as things move off into the distance as we approach the tangible surface?
Good question.
If
I accept that the world is curved, then yes, the floor is not flat.
So
is that the reason why we're seeing this? My gut reaction is no. I don't think the distance is further that far that curvature actually has anything to do with it. So there must be a different explanation. I'm actually serious about doing the experiment on the football field. I'll do it.
Okay. Do you see this picture here?
It's
showing you.
What you're bringing up is a valid point.
Look,
we can't dismiss observable evidence any more than you can dismiss my observable evidence. Let's go see it, and then we have to come up with an explanation.
I'm showing to you right now. We could just redo these same experiments, but they're done here for us. Yeah, we can redo them, but it's the same result.
Forgive me for being a know-it-all, but I have to do it for myself.
Okay, now look. Okay, look. Do you understand? He's showing you here that the same phenomena takes place back to the very beginning of our conversation, that as that boat is moving out, because and due to the same principle that I've been elucidating, the boat appears to disappear even from the bottom up, not due to any alleged curvature of the water. It's disappearing due to simple perspective. Plain and simple, dude.
Well, to this person, it's plain and simple. But, like, for example, this...
No, to reality, to demonstrable reality.
I've heard the accusation that, I just Google stuff. No, I'm going to do this experiment for myself. And I'll show you the data. I'll try to be as transparent as possible. And let's see what happens. I mean, have you ever considered the fact that you might actually convince a physicist that the world is flat? Is that possible? Could you actually do that?
Well, if the physicist was being honest, then they should understand
Well, just like,
intrinsically that the world is.
when I try to say I'm going to convince you that this is, this is what gravity is, I have to. I mean, believe me, if I could show the world is flat, and if you could help me do that, I will. Right here, I'll put it on record. I will give you 50% of my Nobel Prize
The
winnings.
difference is I'm showing you a demonstration. All right.
Yeah, I see the demonstration.
Okay.
But what science is somebody does an experiment, they report
Go.
on it.
You can go do this
That
yourself,
experiment has
dude.
to be repeatable. I will do the
You
experiment for
do
myself
it yourself.
and see if I come up with the same result.
This is the guy at the same lake at nighttime with a flashlight. Okay.
Yeah, fine.
And he even shows you right here that the drop due to Earth curve should be 0.00112.
Yep,
three.
yep, I see. Yep, he's using the equation. Yep.
Okay. So he's showing that the a potential what you phrased your hypothesis that it appears that the water is blocking it is actually impossible, even if you try to account for the alleged curvature, because it is so minuscule at 410 feet that it's basically nothing. You get it?
No, I don't think I will agree with you that I don't actually think that the reason we can't see the objects down that hallway is because of curvature. It's too short of a distance.
Okay, so there's the point. Exactly.
Yeah, no, I agree.
The point is, there's a reason that boats or the sun
doesn't mean I accept the world is flat, but I agree with you that
you don't have to. I'm trying to show you that the idea that things are going over a horizon is debunked as the only possible cause. Therefore, it is no proof at all of curvature.